Hey, what's up, guys? This is Chung here again. So today's daily challenge problem, right? Number 97, interleaving string. Okay, cool. So this one is a very classic, DP problem. So you're given like three strings, right? S1, S2, and S3, and you need to find out if S3 is formed by interleaving of S1 or S2. Okay, so an interleaving of two strings is S and T that is configured where they are divided into non-empty substrings such that basically uh, the pieces of two strings, right, the difference is smaller than one, right? So basically you can either be S1 T1 S2 T2 or T1 S1 T2 S2, right? So for example, right, we have this kind of S1 is this S2, and then we have S3. We can split S1 S3 in this such a way that they can form S3, right? And yeah, and the base case, right, if they're both empty, it's also true, right? So that's it, right? I mean, so one thing I think first thing we have to be we need to notice that actually this thing is actually it's not, it doesn't really matter because as long as you try to place those two strings together, the length of the two parts will always be uh the pieces of two parts will always be smaller than one, right? Because if we have this kind of two strings, right, it doesn't really matter how we split them. Let's say if we split them into this, right, this one and this one. Let's say we split them into three pieces, right? And if we're trying to split this one into one pieces, right? And then if we try to add this one into here, okay, but then the remaining will become one piece, right? So actually it doesn't really matter, how you split this string, as long as you put them together, this thing is always satisfied. Okay, so then then the problem just becomes to we just need to check, for this S3, can it be formed by either by any combination of the S3 or S1 or S2, right? And for this kind of like two strings problems, we always need to have like a two-dimensional DP, right? So in this case, we have DPI and J here, right? So what does this one mean? This one means that from 0 to I plus J in S3, right? I think this is going to be a -1 here because this I and J are one base, From 0 to I plus J -1 in S3, can it be formed by S1 and S2, right? And since we have two strings, right? So we only have one options. Let's say we have this kind of AB. Let's say the I plus J is here. This is the I plus J. Okay. And at this moment, we only have two options. So either this one can match with the with some letters in S1, or this letter can match someone in S2, right? So for example, if this one can match the number, can match the letter in S1, right? Which means that we have, so this letter will be is the same as the I letter in S1. Then it means that we all we need to care is that since we already know, okay, this one matches the S1, so all we need to check is that if the DP of I minus 1 and j, if this one is true, right? Because, since we already know this one can be matched with this one, if the dpi minus 1j is true, then it means that from this whole part is true, right? And another option is that if we also, this one can also be matched with some letters in S2, right? So that's why, there's another option, which is the I j minus 1, right? So if this one is matched with some letters in S2, right? And then if this I j minus 1 is true, and then the whole string is also true, right? Basically, this one is like the S1 I, right, equals to the current letter, right? This one is S2 j, right, equals to current letter, right? And this thing, between this thing is or, right? So either one of them is satisfied, it's fine, right? Basically, we can, with the current I and j, we can utilize the previously, we can basically use the sub problems, a smaller problem, to get to the current one, because like I said, if this one is true and or this one is true, and we can simply use this one plus this, or this one plus this one, to get the current state, right? And in the end, we simply return the dp minus 1 and minus 1, which means that, with everything we have used, is it true, right? Yeah, I think that's it, right? It's a pretty straightforward one, and let's do a dp here. So I'm the length of S1, and the length of S2. If so, we have some special case we can check. So if this one does not, if the total length does not equal to the length of S3, we simply return false, right? And then for dp, we have false, right? N plus 1 for this one in range of n plus 1, right? So very basic dp stuff, since we will be using the dp I minus 1 or the dp of j minus 1, right? That's why, we allocate one more space for this dp, so that so that when we loop through this I here, we can start from 1 instead of 0. So the base case is like this: 0 and 0, right? So 0, 0 means that, there's actually this 0, 0 is example 3 here. That's the base case. And then, since in the DP, we will be using this kind of thing, right? So 1 to n plus 1, right? And then for j in range of 1 to n plus 1. Yeah, because I'm doing this way, basically in this main DP here, I'm assuming, we'll always, both S1 and S2 are not empty, right? So if that's the case, I can just do this dpi and j equals to what? Equals to either this one is either the current one equals to the S1, right? Then that's the S1 dot I minus 1 equals to the S3 dot I plus j minus 1, right? And then we need to check the dpi minus 1j, right? Or like I said, or the current one, what is I plus j minus 1 equal to the S3, right? Which is S equals to S2, j minus 1 equals to S3 dot I plus j minus 1, right? And for this one, we need to check the dp I and j minus 1, right? And in the end, like I said, we simply return the I minus 1, the dp minus 1 minus 1. So that's the two cases, right? Either one of them satisfied is true, and then we know, okay, so this one is true. But as you guys can see here, right? I mean, we start from 1, 1. Okay, we haven't covered the case either I is equal to 0 or j is equal to 0, right? So what does I equal to 0 mean? It means that the S1 is empty, right? J0 means S2 is empty. So for that, we need we can either start from 0, right? And then like this. I mean, if we do this one, in here we have to do a separate handle here, because if one thing is 0, then we don't have any other options. All we have is one options, right? But so I mean, you can do it either way. But in my case, I just pre-process them at the beginning. So in this case, I mean, it's the so this one is the S2 is empty, right? So when S2 is empty, all we need to check is that if the S1 is equal to the S3, right? So we have this 1 m plus 1, right? dp I 0 is equal to dp. So we check if the S1 I minus 1 is equal to the S3 dot I minus 1, right? Because the J, it's the same actually, but the J is 0. That's why we can just use I minus 1 here. And the dp of I minus 1, 0, right? Since we only have one string. Same thing for the other case. S1 is empty. We have J in range of 1 plus n minus n 1 to n plus 1. This time we have 0 dot J S2 dot J minus 1 equals to the S3 J minus 1, and this one dp 0 J minus 1, right? Yeah, so that, I think that's it. If we run the code, accept it, right? Yeah, there we go. I mean, time complexity, m times n, right? Space complexity is also m times n. Yeah. Actually, there's a follow-up, right? So can you solve this when using only a S2 length additional memory space? I think the answer is yes, right? I mean, I think you can just remove one of the dimension from the DP here. Instead of storing the I and J, I believe we can only store J, because as you guys can see, when we use I here, we will only be using I minus 1. So that's why we can reduce this time complexity from 2D to 1D. I guess I'm not going to do it here. You guys can try it out by yourself if you're interested. Yeah, I guess that's it, right? I mean, it's very classic two-string problem, So this one is, I think, is quite similar to that kind of added distance problem, right? You have two strings and then you want to check if you can the distance between two strings. Yeah, very similar, I guess. And yeah, I think I'll just stop here. And thank you for watching this video, guys, and stay tuned. See you guys soon. Bye-bye.